How do you do this stuff? First of all, I want to highlight what's up here. So if you have any base to a fractional exponent, this bottom part of the fraction is always going to be the root, and the top part's the power. Okay? If you have a negative, we've learned this before, if you have a negative, it's 1 over that. It's just 1 over that root and power. Anytime you have any kind of negative exponent, it's always 1 over there. Okay? So these are rules. Some of the rules we've learned before. This one we've learned before, but these are brand new. So let's look at example 1. So first of all, in example 1, the 3 is the root and the 2 is the power. So I'm going to rewrite as the cube root of 8 squared. The 3 is the root and the 2 is the power. Okay. Now, I do know what the cube root of 8 is, and I like to try and do the root first because it makes the number smaller. So the cube root of 8 is 2, because 2 times 2 times 2 is 8. So the cube root of 8 is 2. I got to remember the square. 2 squared is 4. There's your answer. Example 2 works the same way, except we have a negative. So the first thing I'm going to do is apply that negative and make it 1 over. So I apply the negative. It's got a negative exponent. So I make it 1 over, and then I'll do the same thing. I'm going to have the cube root and square. So I'm going to go the cube root of 8 squared, which we already knew. We found out was 4. The only difference in this case is going to be 1/4. Okay. Cube root of 8 is 2. 2 squared is 4. But it's 1 over because of the negative exponent. Okay. Example 3. It's a negative exponent, so it's got to go 1 over. Okay. Negative exponent is just going to be 1 over. So apply the negative. It's going to be 1 over. And then we learned that anything to the 1/2 power is just a square root. Square root of 144 is 12. 12. I sure can, Grace. There you go. Okay. Now in example 4, we're just kind of going to go the other direction. We're going to take it from a root. We're going to take it from a root form into a power form. So it's going to be my 7 to the 2/4 power. That's my power, right? And that's my root, so we write just to the 2/4 power. And of course, that's the same thing as 7 to the 1/2, right? Starting to make a little bit more sense, Felicity. Now, example 5. I like example 5, and I want to be real careful with it. You've got to make sure. A lot of people are going to want to go 25 times 25. You don't do that. And let me show you a really easy example of why. If you had just a little sideboard, little side work here. Okay, if you had 2 to the 3rd times 2 to the 4th. This is really 2 times 2 times 2. There's 3 2's, right? And there are 4 2's, so the answer really is a total of 7 2's. Not 4, right? Not 4. Because this really means 2 times 2 times 2 times a 2 times 2 times a 2 times 2. So what we really have is 7 2's. Do not multiply the bases. They represent how many of these? How many of these? There are 3 2's. There are 4 2's, makes a total of 7 2's. I mean, you wouldn't make it 4. There are no 4's. There are no 4's in this problem, right? Do not multiply. So going back to example 5, what we're really going to do is we're going to add exponents. Because if you have 25 to the 3/5, and you're going to multiply it times 25 to the 2/5, you're going to add fractions. Just like we added fractions over here, we're just going to add our exponents. So we get 25 to the 5/5, which is 25 to the 1, which is just plain old 25. Okay. Now, all of these, yes, can be done on the calculator. They can if you know what buttons to push. However, a lot of the lesson we're going to see today doesn't do numbers, it does x's. So we need to know the rules, right? Yeah, Juan?
When you add the exponents, can they go over the limit? Like, what if it was 3/5 plus 3/5?
Yeah, then in fact, we're going to look at that one.
Okay.
Yeah, then you get a 1 1/5, right? So you get a 25 times the 5th root of 25. Getting ahead of myself, okay? All right, getting ahead of myself. Let's turn the page because we're going to see something like that, okay? On example number 9, Juan, we're going to see that, okay? Okay. All right. Number 8. Let's go back. A little side work on number 8. A little side work. If you had x to the 4th divided by x to the 3rd, you'd subtract exponents. You guys agree with that? So we're going to do the same thing. We're going to have 8 to the 4/3 over 8 to the 2/3, and we're just going to subtract exponents. So we're going to get an 8. 4/3 minus 2/3 is just 2/3. Now that made sense, but I think there's more we can do. If I flip the page real quickly, we said that 8 to the 2/3 was 4, didn't we? So we can take it a little further. So 8 to the 2/3 would be the same thing as the cube root of 8 squared, right? And we just did this one, which the cube root of 8 squared is really going to be the same thing as 4, okay? What's that, Grace? Yeah, which way? Move it down that way? How's that? Okay. Okay, example 7. Let me go ahead and give a little work on the side. If you had, say, an A to the 3rd, B to the 4th, and take the whole thing, say, to the 5th, you would multiply exponents, right? Wouldn't you multiply exponents? You get an A to the 15th, B to the 20th, right? We're going to do the same thing on this one. We're going to multiply exponents. The only problem is the 27 doesn't have an exponent. So we're going to go, okay, 27 to the 2/3 times my x, multiply to the 2/9. Multiply exponents, okay? No, they don't, because we're not adding them. We're just multiplying. So this 27 to 2/3, wait a minute, I think I can do something with that. I can't do anything with this one, but I think I can do something with that. That'd be the same thing as the cube root of 27 squared. X to the 2/9, I just got to leave it as x to the 2/9. I can't do anything with that, right? Cube root of 27 is 3. 3 squared is 9. And that's all I can do. I mean, like 2/9 is 2/9. I can't do anything with it. Okay. Example 8. I'm going to do a little side work for example 8 before I do anything, okay? A little side work. Okay, so let me slide and do a little side work above it. So if we had the square root of, say, let's make it something easy, like maybe 20, and the square root of x, 20x to the, say, 4th, I don't care. You would break this one down, wouldn't you? And it's just a little side work. Just a little side work. You'd break that down, right? You break that down into 4 and 5, right? So what about 56?
8.
Yes. Yes. It is going to be effect worthy. There it is. Perfect cube. 8. 8 times 7 makes 56. And I like the 8 because it's a perfect cube. Nice job, Arthur. So let's rewrite this as the cube root of 8. Oh, that's not good. Cube root of 8 times the cube root of 7, right? That makes 56, doesn't it? But that's a perfect cube. That's going to be 2. I'll come back to it, but that becomes 2. And now the cube root of x to the 9th, I'm going to leave as x to the 9th because I can divide the 3 into the 9 evenly, can't I? I mean, 3 goes to 9 3 times, right? So let's finish this up. Cube root of 8 is 2. We cannot simplify this, so it's going to stay the way it is. Cube root of 7 is some ugly decimal. We leave the way it is. But we can take a third of the 9, which makes an x to the 3rd. So I cube rooted the 8. I cube rooted the x to the 9th. The cube root of 7, can't do it. It's just an ugly decimal, so I leave it where it's at. So it's the same things we've done before. The difference is we're doing it with cube roots and squares. Back up, put that phone away. Okay? Example 9. Alright, example 9. Let's take a look at what we got. We got the 4th root of x to the 10 over the 4th root of x to the 4. Okay? I'm going to answer your question real quick. Okay? Now, the bottom's actually pretty easy. The bottom is because 4 does go into 4, doesn't it? 4 goes to 4 how many times? So this just becomes a plain old x to the 1. I don't need the 1, but there it is. Everybody okay with that? 4 goes into x to the 4th, 1. Or the 4th root of x to the fourth is x, because x times x times x times x is x to the fourth, okay? Now up here, though, I can't really take the fourth root. I can't divide 10 evenly. But I can make it an 8 and a 2. I'm going to make this into an 8 and a 2. I want the 8 because I can divide 8 by 4. So let me rewrite this as the fourth root of x to the 8th times the fourth root of x to the 2. So what I did was I found the biggest amount that I could take and divide it evenly, okay? 8. 8's the biggest number, and what's left over would be the 2. Now that's still, when you think about the 2 and the 8, that's still a 10, right? The 2 and the 8, that's still a 10, but I wanted the 8 because that's the biggest number I can take out to make it divisible by 4. Okay, so let's take this step further. Fourth root of 8, fourth root of x to the 8th is what? Yeah, 2x squared. Totally right. So this is going to be an x squared, and then the fourth root of x squared. Now we can't do anything with that over my x, okay? Want to see what happens when you have some left over? Yeah, you just have it left over, right? Now, I see something right here, and I hope you do too. What do you see there? Just an x. So I'm going to rewrite this as an x times the square root of x. What happened to the 2 and the 4? What happened to the 2 and the 4? Oh man, sorry guys. What happened to the 2 and the 4? It reduced to 2/4 or 1/2. Nice job, Madeline. Okay, last one, huh? So you ready? This could be x to the 2/4. See that, Becca? No, you can't see anything, okay? Here you go. Right here where my finger is can be rewritten as x to the 2/4, right? Couldn't it?
Right.
Right? Here's my power.
Oh yeah, that part.
Right, that part, right?
Circle part.
No, that's just x squared over x, right? You can cancel an x for an x, right? There you got it. But this becomes, you agree with that being an x to the 1/2? And I told you that, where's my reading? X to the 1/2 is,
Oh, and then you cancel.
then I cancel the x, yeah.
I see.
Good.
So why didn't you write the 1 and the 2?
I can, I don't need to, right? Because square root, it's like this, like on the square, you could have a 2 here and a 1 here, but it's kind of dumb.
You can't see it.
Oh, that's not good. There we go. Here we go. So, Becky, you ready? 1/2. I could put a 2 here and a 1 here. We just don't, right?
Why?
We never write. I've seen some calculus have a 2 there. I really have. But we all know that it's a 2. Square root, there's a 2 in there, right? I mean, it's just one of those things we know that we wouldn't write. Okay, last problem. Okay, last problem. Here we go. So, let me rewrite this as the cube root, oh my goodness, the cube root, thank you, of x to the 6th over the cube root of 125 times 2. 250. Let's write 250 as 125 times 2. Now, why would I make 125 times 2? Perfect. You guys are all right because 125 is a perfect cube, right? And the cube root of 125 is 5, right? So this is just going to be an x squared. So take a third of 6, and I get x squared. And down here, I'm going to have a 5 times the cube root of 2. Now, I'm almost done, but I got a problem. Okay? I got a problem. I cannot have, okay, there you go, cannot have a root in the bottom. How do I get rid of this cube root in the bottom? By what? Cube root of what? Cube root of what? It's not 2. It's going to be the cube root of 4. I'm going to go the cube root.
Why 4?
Good question. Why 4?
Oh, because 3 and 2.
Is it because it's going to go into
What's 2 times 4?
8?
2 times 4 is... Here's another way. If you have a hard time, 4 is the same thing as 2 times 2. So I would have a 2 times a 2 times 2, which is... So you see it? So then I'm going to wind up with an answer of x squared times the cube root of 4. That becomes a cube root of 8, right? That becomes a cube root of 8, which is just a 2. So I get a 5.
Like multiplying by the get something that you could, that was a perfect cube?
Yes.
Oh.
Yes. Nicely said. So then my grand answer is going to be x squared, s squared, cube root of 4 all over 10. All right. So we need to do some homework, and I don't mind helping you a little bit.
Break.
We can have a little break.